Hey guys, it's Miss Thompson here with our lesson for box plots. You may remember box plots from before we got out for the break because they're also called box and whisker plots. This first slide is just an anchor chart that you can use for reference. If you get stuck, you can back up the video and look more closely at this anchor chart. Remember, a box plot is a number line using measures of variation to display our data. Remember, we have the lower and upper quartiles or extremes, outliers, median, and then our first and third quartiles. We'll get back into all of that in our iReady lesson. So let's continue. For this week, you are to work the instructional part with me, and then go back and complete the video on your own, including the quiz, because you know I'm not going to do the quiz with you. Or you can complete and submit your workbook pages.
I hear it takes more than an hour for village women to walk down to the river, fill a container of water, and walk back.
Makes me appreciate that all I have to do is turn on the faucet.
And the water isn't even safe for drinking. It's contaminated.
So what does the Fresh Water for All Foundation do to help?
They teach people who live in remote villages how to build community wells in order to access clean, safe water. Look, they're building a well right over there.
So now that the well is finished, the villagers have their clean water.
Well, actually, well building is only a part of my work with the foundation. We also educate the people concerning the dangers of drinking contaminated water.
Why is that still a problem? The village has all the fresh water they need now.
The villagers have been collecting water from the same sources for generations. We need to convince them that drinking water from these locations can be hazardous to their health.
How can we convince them?
Come with me to the lab. I've got some water samples that should give us the proof we need.
I read that bacteria in drinking water is the #1 cause of illness in this region, Dr. Drazel.
Exactly. That's why we've collected water samples from 15 different locations to check for bacteria. If a water sample contains 10 or more bacteria, then the water source is unsafe for drinking. Out of the 15 samples we've collected, there's just one left to analyze. It's from location number 9. Let's see how many bacteria you can spot with the microscope.
Use the knob to sharpen the image of the bacteria. A yellow ring will appear when the image is in focus. Great, the image is in focus. How many bacteria does this sample contain?
Okay, so let's just count. 1, 2, 3, 4, 5, 6, 7.
Exactly.
Let's insert that 7 into our chart and start our analysis. So now that we've collected water samples from 15 different locations, processed them in the lab, and recorded the bacteria counts, it's time to analyze the data.
We need 5 pieces of information to fully analyze the data.
Now, before we go any further, just notice all of these numbers are in chronological order. That helps so much when you get ready to do your box plot. So make sure that when you're working on your own that you put your numbers in chronological order first.
Minimum, maximum, median, lower quartile, and upper quartile. Click on the lowest or minimum number of bacteria found in a water sample.
Okay, remember minimum is your smallest number. So that's 6.
Click on the highest or maximum number of bacteria found in the water sample.
All right, and our maximum number is our highest, which is 25.
The third piece of information we need to find is the median. We can call it M for short. The easiest way to find the median is to remove the lowest and highest numbers in pairs until only 1 or 2 numbers remain in the middle. Click on the median bacteria count of the data set. Use the marker tool to eliminate pairs.
Okay, and you usually can do this with your fingers on paper. There's one there and one there. Not sure where that marker tool went, but that's okay. And there's a pair, and there's a pair, there's a pair, there's a pair, there's a pair. So I'm thinking it's 10, but again, I'm going to check with my fingers. You can't see me doing this, but I'm simply working from each end, moving over one number each time, and sure enough, I land on the 10.
The fourth piece of information is found in the bacteria counts that are less than the median. Click on the median of this part of the data.
Okay, so for this part, you just forget the rest of it for a second and only use the lower part of your information that's under the 10. Find the median of these. You've got 3 on this side, 3 on this side, so obviously 7 is our median or middle number of those.
So this is how we find the first or lower quartile, which in this case is 7.
The last piece of information is found in the bacteria counts greater than the median. Click on the median of the bacteria counts greater than M.
Okay, so again, we do the same thing with the upper end of the information.
So, the median of the values greater than M is called the third or upper quartile, which in this case is 16.
Okay, so now that we have this data, what does it all mean? And how can we use it to convince the villagers to only drink water from the new well?
The easiest way to make sense of this data set is to use a box plot. A box plot starts with the number line. The values on the number line should extend beyond the minimum and maximum numbers in the data set. The 5 values found in our chart are then marked on the number line. The first mark will represent the minimum value found in the data set. Drag the mark on the number line to the minimum value of the data set.
All right, so we will drag to 6. Whoops. There we go.
Drag the mark on the number line to the lower quartile value of the data set.
Okay, so that'll be 7.
Drag the mark on the number line to the median value of the data set.
Just 10.
Drag the mark on the number line to the upper quartile value of the data set.
That's going to be our 16.
Drag the mark on the number line to the maximum value of the data set.
And that will be our 25.
All we have to do to finish the box plot is draw 4 horizontal lines. Top and bottom lines complete our box in the middle, while 2 more lines extend from the box to the outer marks, creating our whiskers. A box plot divides a set of data into 4 parts, 1, 2, 3, 4, using the median and the quartiles. Looking at the lengths of the 4 parts, you may think the 4 parts are not equally divided. But each part contains the same amount of values, which in this case is 3. It's the range of numbers in each part that makes them appear so unequal.
So what you are saying is that even though the 4 parts are different lengths, they each represent 3 water samples.
Yes, each part makes up 25% of all the data. This box, which is known as the interquartile range, shows the middle 50% of the data, while the 2 whiskers show the first 25% and the last 25% of the data.
So I understand that the box plot helps us break up the data into 4 equal parts, but how does organizing the data this way help us show the villagers that the water they have been drinking is not safe?
Well, box plots are useful for analyzing this type of data. It will help us describe the severity of the problem to the villagers.
We know that water samples with 10 or more bacteria are unsafe for drinking. The box plot shows that 50% of the water samples we took are unsafe to drink because they have a bacteria count equal to or greater than 10.
"50%? That's half of the samples we collected, so half of the water samples are dangerous."
Wow, that's not good.
Absolutely not. Let's continue our analysis so we can convince the villagers of the importance of using the fresh water for all well.
What is the range of the data set?
Remember, to find range, we subtract the highest number minus the lowest number. And these numbers are fairly easy, but if not, you do have your little calculator here that you are welcome to use whenever it is available. Okay, so don't forget about your handy tools down there. You're allowed to use those tools anytime that they are available.
The water samples have equal amounts of contamination. Is this statement true or false?
Okay, we have an equal number of water samples, but they don't all have the same amount of contamination. Remember, these had a much higher contamination level.
Water from some sources is much safer to drink than others. Is this statement true or false?
True. I want to drink down here on water from these places.
What is the interquartile range of the dataset?
All right, the interquartile range is going to be 7 minus 16, which would be 9. I just subtracted the upper minus the lower extreme. Quartile, sorry.
So why is the right whisker so much longer than the left?
A few bacteria counts were much higher than the rest. These numbers are called outliers. Outliers are data values that stand out from others in a dataset. The long whiskers indicate that there are 1 or more outliers, and in this case that means danger. That 25 count is 2 1/2 times the contaminated water level.
How did that water source become so contaminated? Can we go and investigate the area?
Samples with high bacteria counts tend to come from areas where people use water for bathing, cleaning, and, unfortunately, drinking.
So that's why the work that the Freshwater for All Foundation does is so important.
I know. Let's put up a sign to inform the villagers of the dangers of drinking the water here.
Great idea.
Okay, let's close this out. And remember, your link is here. Also, just a reminder, you do have this anchor chart that explains everything step by step. You're welcome to freeze that screen or open another window to do your video in one window and have this open in the other as a reference. All right, also remember to ask your teacher if you have any questions or problems. You can chat through Canvas, remind through your parents, and we will Zoom on Friday. Bye. Have a great afternoon.